So the next radiation, number 3, is gamma. So number 1, it is electromagnetic radiation. Number 2, it has no mass and no charge. Its symbol is this gamma. Next, it is emitted from the nucleus with speed, exactly speed of light, which is 3 into 10 power 8 meter per second. Mean speed is represented by c. And the next, it penetrates into air few kilometer. Its penetration power is maximum, greater than alpha, greater than beta. It is blocked by thick lead. Alpha is stopped by the paper, beta is stopped by the aluminium, but the gamma is stopped by the thick lead. It has very, very small ionization ability, ionization power, just 1 ion pair in 1 millimeter distance. Mean 1 can be written as 10 power 0. For the alpha, the power is 5. For the beta, it is 3. And for the gamma, it is 10 power 0. So its ionization power is very, very small. Next, after the emission of the gamma, there is no effect on the proton number. There is no effect on the neutron number. There is no effect on the mass number. Mean when X element is emitting gamma radiation, there will be no effect. It will remain the same element, but the gamma is emitted. So the emission of the gamma leaves no effect on the proton number, mass number. So nothing is emitted in the form of the particle, so the nucleus remains same. So this emission cannot be drawn on the graph like alpha emission and beta emission. And the next, it has no charge. So it goes straight, it goes undeviated through electric and magnetic fields. No deflection, no deviation, it goes straight. Now the conclusion is, if we have this cloud chamber, which contains the vapors of water and alcohol, and here is a source which is emitting 3 types of the radiation, alpha, beta, and gamma. So if alpha is emitted, then the tracks in the cloud chamber will be straight. And these tracks are formed by the ionization of the alpha particle, ionization of the vapors. So they will appear as a spark. Discharge of the ion will produce the light. So if the light track are straight, it means the alpha particle is emitted from the radioactive nucleus. So tracks are straight because it's a heavy charge particle, so it goes almost straight up to 4 centimeter. And if this is the same cloud chamber, and here is a nucleus, radioactive sample, which is emitting beta, So if the tracks are curved, straight, then the beta particle is emitted by this radioactive element, because the beta is a light particle. During collision with the other particles, it cannot maintain its linear momentum. So due to the light particle, it goes zigzag, and this zigzag light mean these are actually the tracks of the beta particle. If the tracks are continuous and the zigzag, this is the beta particle. And now, if this is the cloud chamber and this nucleus, this radioactive sample is emitting gamma, so there will be few cloudy tracks, because gamma ionizes the air hardly. So few tracks. So just 4 or 5 spread flashes of light, then this is emitting the gamma. So gamma, beta, and alpha. So these are the tracks of alpha, beta, and gamma in the cloud chamber. Okay, now the last topic is alpha scattering experiment. Now suppose here is a alpha gun or any radioactive sample which is emitting alpha particles. Alpha particles are positively charged. So the symbol for the alpha, either this or He24. So positively charged particles are coming from the source. And here is a gold foil. Now the alpha particles are forced to pass through the gold foil. And here is a detector, any fluorescent screen. Suppose this is a curved glass sheet which is coated with zinc sulfide. It's a fluorescent screen. When the alpha particle strikes a fluorescent screen, it glows. Now, suppose we have here the nucleus of the gold, and this is the atom size. It's very, very small, but suppose this is representing the nucleus, this circle is nucleus, and the outer dotted circle is the size of the atom. Now the alpha particle, number one, which is traveling in this direction, when approaches close to this nucleus, due to repulsion between the similar charges, so it deviates little from its actual path. And the alpha particle number two, when approaches this, the distance between the alpha and the nucleus is small, so there will be the large deflection, larger than the previous. And this number three alpha particle is going straight, almost colliding head on. So it is repelled by the nucleus exactly at 180 degree, large deflection. Now this alpha particle number four will deflect in this direction. This alpha particle will deflect in this direction, and this alpha particle will deflect least. So the deflection angle depends on the distance of the alpha particle while passing through the atom from the nucleus. Larger the distance from the nucleus, smaller the deviation. Now in this experiment, Rutherford, Geiger, and Merson, three scientists, discovered that, number one, the discovery from the alpha scattering experiment, number one is the vast majority of alpha particles passes through the foil, mean this gold foil, with very little or no deviation. So I repeat, the vast majority of the alpha particle mean will go almost straight or will show the small deviation. Number two discovery is a small number of the alpha particles mean the alpha particles were deviated through an angle of more than about 10 degree. Mean their angle of deviation more than 10 degree, they were very small. And the third discovery is, number three, an extremely small number of the particle. An extremely small number of the particles were deflected through an angle greater than 90 degree. An extremely small number of the particles were deflected through the angle greater than 90 degree. Extremely small. So what's the ratio? 1 out of 10,000 alpha particle. If 10,000 alpha particles were bombarded on the gold nucleus, on the gold foil, only one alpha particle, yes, will be deflected with the angle greater than 90 degree. So these are the three discoveries. Now, next, what is the conclusion? What is the observation? What is the result from these two? So result number one is the majority of the mass of an atom is a very small, the majority of the atom is in very small volume at the center. Because most of alpha particles would pass through the foil almost undeviated. Mean the major portion of the atom is empty. The majority of the mass of the atom is very small volume, in a very small volume at the center, mean the rest is empty. And the number 2 conclusion is the center of the atom definitely it is called nucleus is charged because alpha particle which are also charged passing close to the nucleus will experience a large repulsive force, causing them to deviate from its actual path. It means the charge of the alpha and the charge of the central part is similar because there is a repulsion. So both are similarly charged. So alpha is positively charged. So the central part, which is called nucleus, is also the positively charged. And the third is only alpha particle that pass very close to the nucleus, almost striking it head on, will deviate or will experience a large repulsive force to cause them to deviate through an angle greater than 90 degrees. Now, this fact, this one, the last one, this shows that the nucleus is very small in size, but positively charged and dense. So the final conclusion from this is most part of the atom is empty space. Only the central part is dense, positively charged, and called nucleus. So this is the discovery, and this is the result of the alpha scattering experiment.